Hello again everyone and welcome to 5-Minute Physics. Today's topic is resistors in series. Alright, now before we get started, let's talk a little bit about what that means. Resistors in series is... having resistors in series is a way of organizing a circuit in which all the resistors are in a single path. So there is one path from one pole of the battery through the resistors to the other. It doesn't branch off. The wire doesn't branch off. It's one path. Resistors in a series all carry the same current. So even though the resistance might be different among them, the current through them is always the same. And one last thing we need to know before we start our practice problem is equivalent resistance. The equivalent resistance to a circuit is what you would get if you combine the resistance from all of the resistors on the circuit. So let's say you had one with a resistance of 4 ohms, one with a resistance of 2 ohms, and one with a resistance of 1 ohm. The equivalent resistor would be worth 7 ohms, because that's what you would get if you added up the resistance of all of those 4. Okay, well, of those 3, sorry, my bad. So here's our question. A 9-volt battery is connected to 4 light bulbs. Find the equivalent resistance for the circuit and the current in the circuit. Okay, so let's approach this problem first by drawing a diagram. So there's a diagram, and we have resistors 1 through 4, with resistor 1 having a resistance of 2 ohms, resistor 2 having a resistance of 4 ohms, resistor 3 having a resistance of 5 ohms, and resistor 4 having resistance of 7 ohms, with a charge on the battery of 9 volts. Alright, now let's approach the problem. We'll start out with our given find. So givens, we have delta V is 9 volts, R1, the first resistor, is 2 ohms, R2 is 4 ohms, R3, oh, that's a B, not an R. R3 is 5 ohms. Let's make that look like a 5, there we go. And R4 is 7 ohms. Alright, now what do we need to find for this equation? We need to find the equivalent resistance for the circuit and the current in the circuit. So that would be R equivalent. We gotta find that. And I, the current. Gotta find that also. And what equations are we going to use? Let's see. Let's use the equation for resistance, which is delta V is equal to IR. And if we want to rearrange that to find I, that could come in handy later. So that would be delta V over equivalent resistance. Rec. That's what it looks like. Okay. So we're going to start out by substituting the values here. So let's see. The equivalent resistance is the addition of all of the resistance of the existing resistors. Excuse me. So, to set up an equation, we have equivalent resistance equal to 2 ohms plus 4 ohms plus 5 ohms plus 7 ohms. And all added up, that is equal to 18 ohms. So there's our equivalent resistance. Now we need to find the current. So looking back at our equation, we have I equal to delta V over the equivalent resistance that we just found. So let's set that up. We have I is equal to the equivalent resistance, which was 18 ohms. I'm sorry if that's a little bit small here. Let me zoom in. Divided by... Oh, did I mess up? Yes, I did. That goes on the bottom. Sorry. My mistake. Delta V goes on top. So we have 9 volts on top, and the 18 goes on the bottom. 18 ohms. So we solve for that, and we end up with a current of 0.5 amperes, or amps. And for resistors connected in series, the equivalent resistance should always be greater than the largest resistance in the circuit. So here our largest resistance was 7. Is 18 greater than 7? Yes, indeed it is. We're golden. Alright, so there's our sample question. Too far. That's all for resistors in series. Thanks for watching, and I'll see you next time.